Friends, in last class already we are discussed about capacitance and capacitors concept. Capacitance means C is equal to Q by V. We are informed for that one farad is a unit, and also we are identified capacitance of isolated sphere C is equal to 4 pi epsilon naught R, and also we are mentioned capacitance of isolated sphere is not depends on charge, and it's only depends on nature of the surroundings medium and its dimensions of the given sphere. Like that, in last class already we are discussed. So now in this class we want to discuss about capacitance of a parallel plate capacitor. So friends, our intention is we want to find out expression for the capacitance of a parallel plate capacitor. In parallel plate capacitor, we are taking two plates. One is we are giving a charge plus Q, and another one is we are giving a charge minus Q. If suppose when the charge plus Q is given to a one of the plate, that plate having surface density is plus sigma, and when we are given a charge minus Q to a plate is that is having surface charge density minus sigma. If suppose here I am representing one parallel plate capacitor like this. For example, this is one plate and this is another plate. These two plates I am taken having areas capital A only. These two plates we are separated by distance small d. So when we are giving a charge plus on first plate, that is having surface charge density is sigma. When we are giving a charge minus Q on a second plate, means that is having a surface charge density minus sigma. If suppose when giving a charges between these two plates, means compulsory electric field will be developed, that is coming from positive plate to negative plate. Here electric field lines we are observing all are parallel to each other like this. So friends, already in between the parallel plates electric field is developed. We know by previous knowledge electric field intensity from a sheet is E value is equal to sigma by 2 epsilon naught. That is the fundamental formula for electric field intensity developed by the charged sheet. Once I am repeating, for a sheet E value is equal to sigma divided by 2 epsilon naught. Here how many sheets is present? 2 sheets is present. So in between the two plates, the resultant electric field is we are taking as E value is equal to, I am representing as a sigma divided by 2 epsilon naught plus a sigma divided by 2 epsilon naught. This is for one plate and this is for another plate. So by summation these two we are representing like this, E is equal to sigma by epsilon naught. So further we know very well surface charge density is nothing but charge per area of that surface. So sigma is equal to Q by A, that is one fundamental formula we have. So instead of sigma, just we are substituting the value like this, Q by A. So therefore finally we are getting here capital E value is equal to, we can able to write that one as Q divided by A epsilon naught. So let friends, this is we are taken as equation 1. So further we are ready to discussing about potential developed between the plates. So for example, the potential between the plates we have is V is equal to capital E into D. This is by the relation between electric potential and electric field intensity. Since this relation is we can able to remember like this, by the relation between electric potential and electric field intensity, E is equal to minus dV by dr. From that only here we are represented V is equal to capital E into D, or capital E is equal to V by D. So let that equation we are taken as 2. So friends, we have two equations were identified for capital E. One is E is equal to Q divided by A into epsilon naught, that is first equation, and one more equation is E is equal to V by D. If suppose on equating the both the equations 1 and 2, we can able to write like this, V by D is equal to Q divided by A into epsilon naught. Once I am repeating, V by D is equal to how much we are observed here, V by D value is equal to Q divided by A into epsilon naught. So friends, on equating further we are just rearranging the equations like this. Here V by D is equal to, we have Q divided by epsilon naught A. So then we can able to write like this, Q by V is equal to epsilon naught A by D. So therefore epsilon naught A by D is equal to Q by V. So epsilon naught A by D is equal to, I can ready to represent that one as C. By reason is, we know very well by the concept of capacitance, C is equal to Q by V. Therefore C is equal to epsilon naught A by D. So these are the just fundamental formula about capacitance of a parallel plate capacitor, that is C is equal to epsilon naught A by D only. So from this one we can just guessing as C is proportional to area of the plate and C is inversely proportional to the distance between the two plates. If suppose in between the two plates we are placing one dielectric medium or dielectric slab we are placed, means now how we are representing that notation, means we want to discuss now. Okay, friends, now between the plates we are representing or we are placing one dielectric slab or dielectric medium. That medium is having permittivity like this, that is we are represented as epsilon m. So C medium is equal to, we are representing as epsilon m A by D. So C medium is equal to, instead of epsilon m or epsilon, that is nothing but permittivity of mediums, already we know that is K times of epsilon naught. So here K is we are taking as a dielectric constant of the given material and epsilon naught is the permittivity of free space or permittivity of air medium. So C medium is equal to, we can able to write like this as, instead of epsilon m, K into epsilon naught into A. So this is K times of epsilon naught A by D. So this is K times of epsilon naught A by D like this. So after getting this one, C medium is also represented like as K times of C air. So C medium value is equal to K times of C air. This is the relation between capacitance between the plates when air medium is present and also and any other medium is present like that. So friends, now we want to discuss one thing. Till now we are discussed in between the parallel plates, both the plates are having same area A. For example, now I am mentioning like this. For example, this is one plate is present and this one is another plate is present. Here both the plates are not having same area and one is having a large area and another one is having small area. For example, this plate having area AL and this plate is having area AS. Now the capacitance developed between these two means we can represent like this as C is equal to epsilon naught A, epsilon naught into AS by D. Here which area we are preferred? Which one is the least value or least surface area value, that only we are choosing. So in this situation we may observe C value is equal to epsilon naught AS divided by D. Here large area value we are unable to guess. So next, in between parallel plates, one more concept also we want to discuss, that is fringing of electric field, or simply we may calling that one as fringing. So till now we are not yet discussed a few things in last concept. Okay, for example, this is one parallel plate capacitor. In this parallel plate capacitor, two plates are separated by a small distance d. So for example, one plate is charged plus charge and another one is given a charge minus charge. So here electric field is developed between these two plates, okay, like this. All these electric field lines are present parallel to each other. This is in between the charges or in between the charged plates we are observed. But here in diagram we are observing at the edges of these plates or at the corners of these plates some curved electric field lines we are observing like this. For example, this is one curved field line and this one is a curved line or electric field line is present. Similarly, this direction is also we are observing. So at the edges or at the corners of the parallel plate, okay, parallel plates in capacitor, some bending of this okay, electric field lines we are observing. Those things only we are calling as fringing. So how to explain this one means, in case of a parallel plate capacitor, the electric field lines are parallel to each other, but at the edges or at the corners of the plate, field lines are curved or bended. This is known as, we may calling as fringing of electric field, or simply we are calling as fringing. This is the simple concept and easiest concept. At curves, okay, and curved lines were observed at the corners of the plates in a parallel plate capacitor. This only we are calling as fringing. Okay friends, now we want to discuss about effect of dielectric of a capacitance. For example, we know very well, we have the formula C is equal to epsilon naught A by D in a parallel plate capacitor concept. For example, here the one parallel plate capacitor we are taking. For example, this is one parallel plate capacitor. Here positive charge is given to this plate, and for this plate we are given negative charge. So in between these two some distance were maintained, that is D. If suppose in between the plates we are introducing one dielectric slab or one dielectric medium, that dielectric medium or dielectric slab having thickness T. Now in this situation, this dielectric slab having dielectric constant K also. Now how to represent the capacitance value in this situation means, we can able to write like this: C medium is equal to epsilon naught A by D minus T into 1 minus 1 by K. So once I am repeating the formula, C medium value is equal to, what's the thing here, epsilon naught A divided by D minus T into 1 minus 1 by K. Here small d is we are taken as a separation between the plates, A means area of the plates, and T is thickness of the dielectric slab, and K is dielectric constant or dielectric constant. K value is dielectric constant. If suppose friends, the gap is completely filled with dielectric slab, means in a parallel plate capacitor. So if gap is completely filled means, what the thing we will get here, small d value is equal to T, means here separation between the plates is equivalent to thickness of that given dielectric medium or dielectric slab. In that condition, we have already one formula, C medium is equal to epsilon naught A by D minus T into 1 minus 1 by K. Here instead of T I am substituting D. So further this equation we can represent like this: epsilon naught A divided by D minus, instead of T we are choosing here small d only, D into 1 minus 1 by K. So on simplification, this one we can written as C medium is equal to epsilon naught A by D minus D. Here minus of minus is becomes plus D by K. Here minus D and plus D will be cancelled. Finally we will get as epsilon naught A divided by D by K. This is also represented as K into epsilon naught A by D. So therefore here also we are observed C medium value is equal to K times of C air. Here also C medium value is equal to K times of C air medium. Okay friends, now we want to discuss one more case in that same concept. First, initially the plates two are separated by a distance d. If suppose one of the plate is displaced, okay, or away like this, or displaced some distance x like this. See here I am representing heading like this: the capacitance of the arrangement when the separation between the plates is increased by x, then what is the thing we are getting? So here totally the distance between two plates now becomes as a d plus x. We are ready to represent like this. Now the new equation in this case for capacitance between parallel plates is C medium is equal to epsilon naught A by d plus x. Previously we are represented here only d. Here length how much increases? X is increases. So instead of d, now we are taken d plus x. Here as usual in a previous way we are represented here minus t into 1 minus 1 by k. So when a distance is increases up to x means C medium value is equal to epsilon naught A by d plus x minus t into 1 minus 1 by k. This is the one of the formula. These formulas are very important for objective examinations. Okay friends, till now we are ready to placing only single dielectric slab between the parallel plates in a parallel plate capacitor. Now we are ready to going for multiple dielectric mediums. Means here I am taking so many dielectric mediums. Okay, each one is having thicknesses here as T1 comma T2 comma T3 comma so on Tn. So all these dielectric slabs were placed in between the plates of capacitor. For example, here this is one plate of the capacitor. Let this is I am represented as a positively thing, and this is another plate, just that is we are giving as a charge minus here. So totally this gap is filled with different dielectric slabs. Okay, how we are substituted means this is first slab having thickness T1, that is having dielectric constant K1, and second one is having dielectric constant K2, that is having thickness T3, and third one is having dielectric constant K3, and that thickness is T3. Similarly, here how many plates we are represented here? N plates is represented. For nth plate, dielectric constant value is here Kn is present, that is having thickness Tn. So this is completely filled without any air gap. So here what's the thing, friends? The distance between the plates is equal to sum of the thicknesses of this individual plates. So d value is equal to, now we are represented as T1 plus T2 plus T3 plus so on Tn. Now in this situation, new capacitance value how we are represented means C medium is equal to epsilon naught A divided by T1 by K1 plus T2 by K2 plus T3 by K3 plus so on Tn by Kn. So this is the formula we have. For example, simply for remembering sake, we are represented as C medium is equal to epsilon naught A by sigma of thickness of the medium divided by dielectric constant. So this is the one of the formula, and this is also very important for objective purpose, objective problems. For solving objective problems, all these formulas we are ready to using. Okay friends, in next class we will go for combinations in capacitors, that is nothing but series combinations and parallel combination. So thank you friends.